Have you ever looked up at the night sky and marveled at how the universe seems so vast, yet so perfectly arranged? Stars twinkle in intricate constellations, galaxies swirl in spiraling patterns, and even the smallest details of nature, like a snowflake or the branching of a tree, carry a sense of order and beauty. But here's the thing: beneath all this elegance lies chaos. The universe, at its core, is a paradoxical interplay between disorder and structure, a symphony where chaos creates order, and order sometimes dissolves back into chaos. It's a mesmerizing idea, isn't it? The universe, this immense expanse of energy and matter, operates in a way that seems to defy randomness. From the birth of galaxies to the intricate dance of electrons within an atom, there's an underlying system at work. But the deeper you dive, the more you realize that what appears orderly is often born from chaos. And what seems chaotic can harbor hidden patterns. This duality is one of the most fascinating aspects of existence, and offers a lens through which we can better understand the cosmos and ourselves. Think about the birth of a star. It begins in a chaotic swirl of gas and dust, a mess of matter floating in the vastness of space. Gravity takes hold, pulling particles together, compressing them into a dense core, and eventually igniting nuclear fusion. What was once a scattered cloud becomes a luminous star, a beacon of light and order in the darkness. Yet even that star will one day collapse, perhaps exploding in a violent supernova, scattering its elements back into the cosmos to seed new stars, new planets, and even the building blocks of life. Chaos begets order, and order begets chaos in an endless cycle. This interplay isn't just a feature of stars, it's everywhere. Take a closer look at Earth. Weather systems, for example, seem wild and unpredictable. Storms swirl, winds howl, and rain pours, creating what looks like a chaotic mess. Yet from these turbulent processes arise predictable patterns: the seasons, the water cycle, the way hurricanes spiral in mathematically precise forms. Life itself, with all its complexity and diversity, is born from a chaotic mix of molecules that somehow organize into cells, organisms, and ecosystems. The very fact that you're here, reading this, is a testament to the universe's ability to create order from chaos. What's truly astonishing is that this isn't just a poetic idea, it's backed by science. At the heart of it all is a principle called entropy, a measure of disorder in a system. According to the second law of thermodynamics, entropy tends to increase, meaning the universe naturally drifts toward chaos. And yet, within this drift, local pockets of order arise. Stars form, planets emerge, and life finds a way. How? Why? What are the rules that govern this cosmic dance? These are the questions that have fascinated scientists, philosophers, and thinkers for centuries. The answers aren't simple, but they're incredibly rewarding to explore. Some of it comes down to the fundamental forces of nature: gravity, electromagnetism, nuclear forces that guide how matter interacts. Some of it lies in the mathematics of complexity, showing us how simple rules can lead to intricate patterns, like the branching of rivers or the veins in a leaf. And some of it, perhaps, is still a mystery, a reminder that there's so much we don't yet understand about the universe. But this interplay between chaos and order isn't just a scientific curiosity, it's deeply philosophical too. What does it mean that the universe can create beauty and complexity out of randomness? Does it suggest a deeper meaning, a cosmic purpose, or is it simply the way things are, a natural consequence of the laws of physics? And what about us, as humans? Are we simply tiny, insignificant specks in this vast, chaotic system? Or is there something extraordinary about our ability to observe, understand, and even influence the patterns around us? These questions have been at the heart of human thought for as long as we've been able to wonder. Ancient cultures saw patterns in the stars and used them to navigate, to tell stories, and to seek meaning. Philosophers debated the nature of order and chaos, trying to understand whether the universe was ruled by randomness or by some underlying logic. And today, scientists use powerful tools, from telescopes to particle accelerators, to probe deeper into the fabric of reality, uncovering new layers of complexity and connection. What's fascinating is how often we find parallels between the cosmic and the everyday. The same principles that govern the formation of galaxies also shape the way water flows in a river, or how populations of animals rise and fall over time. The same mathematics that describe the patterns of a snowflake can also describe the behavior of financial markets. It's as if the universe is speaking a language of order and chaos, one that we're only just beginning to understand. And here's where things get truly exciting. The more we learn, the more we see how connected everything is. The atoms in your body were forged in the heart of a star billions of years ago, scattered across the cosmos, and eventually brought together to create you. The air you breathe is shaped by weather systems that span continents. The thoughts you're having right now are made possible by electrical signals firing in your brain, following patterns that emerged from billions of years of evolution. You are, in a very real sense, a product of the universe's ability to create order from chaos. But this isn't just about understanding where we come from. It's about imagining where we're going. If the universe has a natural tendency to create order, what does that mean for the future? Will we continue to find harmony in the chaos, or will entropy ultimately win? Can we, as humans, play a role in shaping the patterns around us, or are we simply along for the ride? These are questions worth pondering, not just because they're intellectually fascinating, but because they touch on what it means to be alive, to be part of this grand cosmic symphony. So, as we embark on this journey into the dance of chaos and order, let's keep our minds open and our curiosity alive. The universe has so much to teach us, not just about the stars and galaxies, but about ourselves. It's a story of transformation, of cycles, of balance. A story that's still unfolding, with each of us as a small but vital part. And as we explore how chaos creates order, and how order sometimes dissolves into chaos, one thing becomes clear. The universe is more interconnected, more intricate, and more awe-inspiring than we could ever have imagined. When you think about chaos and order, they might seem like opposites, locked in an eternal struggle. Chaos conjures images of randomness, unpredictability, and destruction. A storm ripping through a forest, or the jumble of thoughts in a restless mind. Order, on the other hand, feels stable, structured, and harmonious, like a carefully arranged garden or the ticking of a clock. But in truth, chaos and order aren't enemies. They're partners in an intricate dance that shapes everything in the universe, from the swirling of galaxies to the delicate patterns of a butterfly's wings. To understand this relationship, let's start with what we mean by chaos. In everyday language, chaos often refers to complete disorder, a state where nothing makes sense. But in science, chaos has a much more specific meaning. It refers to systems that are highly sensitive to initial conditions, what's often called the butterfly effect. The idea is that tiny differences in a starting state can lead to wildly different outcomes over time. Imagine a butterfly flapping its wings in Brazil, and that small motion setting off a chain of events that eventually causes a tornado in Texas. It's not that the butterfly caused the tornado directly, but rather that its motion was part of a complex, interconnected system where small changes can have big impacts. What's fascinating about chaotic systems is that while they may appear random on the surface, they often follow underlying rules. Weather patterns, for example, are chaotic. We can't predict with absolute certainty whether it will rain next month, but we do know the seasons will change and storms will follow certain general behaviors. Chaos doesn't mean a lack of structure. It means a level of complexity that's difficult, if not impossible, to fully predict. On the flip side, we have order. Order is what happens when patterns emerge, when things fall into place in a way that feels stable or predictable. The planets orbit the sun in a consistent, reliable rhythm. A snowflake forms with perfect symmetry, no matter how chaotic the conditions in the cloud around it. Even the way your body operates, your heartbeat, your breathing, your thoughts, relies on an intricate system of order that keeps everything running smoothly. But here's where it gets really interesting. Chaos and order are deeply intertwined. They're not separate states so much as two sides of the same coin. In fact, many systems in the universe operate in what's known as the edge of chaos, a delicate balance between too much order and too much chaos. This is where the magic happens. Too much order, and a system becomes rigid and unchanging, unable to adapt or grow. Too much chaos, and it falls apart, losing any sense of structure. But at the edge of chaos, you find creativity, innovation, and complexity. Take life, for example. Living organisms are incredibly complex systems that exist at the edge of chaos. Your body is constantly maintaining order, keeping your temperature stable, your heart beating, your cells functioning, while also adapting to changes in your environment. If things become too chaotic, you get sick or injured. If things become too orderly, life stops altogether. It's this balance that allows life to thrive, to evolve, and to innovate. The same principle applies on a cosmic scale. Think about the formation of stars. It starts with chaos, a cloud of gas and dust drifting through space, particles colliding and moving in seemingly random directions. But over time, gravity takes hold, pulling matter together into a dense core. As pressure and heat build, nuclear fusion ignites, and a star is born. What was once a chaotic swirl becomes a source of light and energy, a symbol of order in the universe. Even more fascinating is how order and chaos seem to feed into each other. A star, for all its brilliance, is not eternal. Over millions or billions of years, it will burn through its fuel, eventually collapsing or exploding in a dramatic supernova. The elements it scatters, carbon, oxygen, iron, become the raw materials for new stars, planets, and even life. Out of the chaos of the explosion comes new order, and the cycle begins again. This interplay isn't just limited to the grand scale of the cosmos. You can see it in the patterns of a river. As water flows downhill, it carves paths through the landscape, creating intricate networks of tributaries and streams. On the surface, the flow of water might look chaotic, constantly shifting and changing, but underneath, there's a clear order to how rivers form and evolve. Following the principles of physics and geology, chaos gives rise to order, and order shapes chaos in return. Mathematics also reveals this connection. Fractals are a perfect example. These are complex, self-repeating patterns that emerge from simple rules. Think of the branching of a tree, the veins in a leaf, or the jagged outline of a coastline. These patterns look intricate and chaotic at first glance, but they're governed by mathematical principles that repeat at different scales. Fractals show us that even in what seems random, there's a hidden structure waiting to be discovered. But why does this matter? Why should we care about the relationship between chaos and order? For one thing, it helps us make sense of the world. Understanding how chaos and order interact gives us a framework for understanding everything from natural disasters to the stock market. It shows us that what might seem random or unpredictable often follows deeper patterns, even if those patterns are difficult to see. It also reminds us of the beauty and complexity of the universe. The fact that chaos can create order and that order can dissolve back into chaos is a testament to the interconnectedness of everything. It's a reminder that the universe is not just a collection of random events, but a dynamic, evolving system where every piece plays a role in the larger whole. Perhaps most importantly, the relationship between chaos and order has something to teach us about ourselves. Life is full of uncertainty, full of moments that feel chaotic and out of control. But those moments are also opportunities for growth, for creativity, for finding new ways forward. Just as the universe thrives at the edge of chaos, so do we. It's where we learn, adapt, and discover what we're capable of. So, as we explore the nature of chaos and order, let's keep in mind that they're not opposing forces. They're partners in a dance that shapes everything around us. From the tiniest atom to the vastness of space, chaos and order are constantly interacting, creating the patterns and structures that make up our world. And in that dance, there's a lesson that even in the midst of chaos, there's beauty, meaning, and the potential for something extraordinary. Nature is full of patterns, from the spiraling arms of galaxies to the delicate veins of a leaf. These patterns are everywhere, weaving through the fabric of the world we inhabit. At first glance, they might seem like a product of deliberate design, something too intricate to have arisen by chance. But what's truly fascinating is that these patterns often emerge spontaneously from the interplay of simple rules and chaotic forces. This phenomenon, known as emergence, is one of nature's most mesmerizing tricks. Emergence is the process by which complex and organized systems arise out of simpler interactions. Think of it as the art of the universe taking simple ingredients, like gravity, energy, and matter, and creating something stunningly intricate. It's not about control or planning. It's about how the underlying rules of physics, chemistry, and biology come together to create order where there was once chaos. Let's start with one of the most recognizable patterns in nature, the spiral. You see it in everything from the arms of a hurricane to the structure of a sunflower to the swirling form of galaxies. Spirals are not random. They are the result of specific forces at work. In sunflowers, for example, the seeds grow in spirals to maximize space and ensure each seed has room to grow. This arrangement follows the Fibonacci sequence, a mathematical pattern where each number is the sum of the two preceding ones. It's a simple rule, yet it creates a form that's both efficient and beautiful. The same goes for fractals, another iconic example of natural patterns. Fractals are self-similar structures that repeat at different scales. You see them in the jagged edges of a coastline, the branching of trees, and even the patterns of your blood vessels. What's remarkable about fractals is that they can be generated by simple mathematical rules. A tree, for instance, grows by splitting its branches over and over again, following basic principles of geometry and physics. The result is a structure that looks complex, but is rooted in simplicity. One of the most fascinating aspects of emergence is how it creates patterns in seemingly chaotic systems. Take weather patterns, for instance. At first glance, the atmosphere might seem like a chaotic mess, with winds blowing in all directions and temperatures fluctuating unpredictably. But within that chaos, larger patterns emerge. Hurricanes, for example, are organized systems that form when specific conditions, like warm water and atmospheric pressure, come together. The swirling structure of a hurricane isn't designed or controlled. It's an emergent property of the forces at play. You can also see emergence in the behavior of animals, especially in groups. Consider a flock of birds in flight. The way they move together, swooping and shifting as one, seems almost magical. But this coordinated behavior doesn't come from a leader giving orders. Instead, each bird follows a few simple rules. Stay close to your neighbors, avoid collisions, and align with the direction of others around you. These basic interactions create the stunning patterns we see where the group moves as if it's a single, unified organism. Another example is the way ants build their colonies. No single ant oversees the construction of intricate tunnels and chambers. Instead, their behavior is guided by local interactions, pheromones that signal where to dig, where to place food, and where to expand. The result is a complex, efficient structure that emerges from the collective actions of thousands of individual ants, each following simple rules. Emergence isn't limited to biological systems. You can see it in the formation of crystals, where atoms and molecules arrange themselves into orderly structures. Snowflakes, for instance, are born from water molecules freezing into a six-sided pattern. The incredible diversity of snowflake shapes arises from tiny variations in temperature, humidity, and other environmental factors. No two snowflakes are exactly alike, yet they all share that same underlying symmetry. A perfect example of order arising from seemingly random conditions. Even in the vastness of space, emergence is at work. Stars and galaxies form through the gravitational pull of matter, creating structures that seem almost sculpted. On a smaller scale, planets like Earth develop weather systems, ecosystems, and landscapes that reflect the interplay of countless forces. The dunes in a desert, for instance, are shaped by the wind, their rippling patterns reflecting the natural flow of air and sand. What makes Emergence so captivating is how it bridges the gap between chaos and order. It shows us that even in systems that seem unpredictable or messy, there's often an underlying logic, a set of rules or forces that guide the formation of patterns. These patterns aren't imposed from the outside. They arise naturally, spontaneously, as a result of the system's dynamics. Emergence also challenges the way we think about complexity. We often assume that complexity requires a designer or a plan, but nature shows us otherwise. From the spiraling shells of mollusks to the clustering of galaxies, complexity can arise from simple beginnings. It's a humbling reminder of how powerful the basic rules of the universe can be. But emergence isn't just a scientific concept, it's also a source of wonder. There's something deeply satisfying about seeing the connections between seemingly unrelated phenomena when you realize that the same mathematical principles govern the growth of a fern and the formation of a lightning bolt. It's hard not to feel a sense of awe. It's as if the universe is speaking a universal language, one that we're only just beginning to understand. Emergent patterns also inspire us as humans. They remind us that beauty and complexity can arise from the simplest of actions, and that even the smallest changes can create something extraordinary. Just as a flock of birds creates intricate patterns by following a few basic rules, we too can shape our world through our choices and interactions. As we marvel at the patterns in nature, it's worth asking, what can we learn from them? How can the principles of emergence help us understand the world, solve problems, or create something new? Whether it's designing more efficient systems, improving our understanding of ecosystems, or simply finding joy in the beauty around us, the art of emergence has much to offer. Nature's patterns are more than just aesthetic. They're a reflection of the universe's ability to create order and complexity from chaos. They're a reminder that even in the most unpredictable systems, there's a hidden structure waiting to be discovered. And as we continue to explore the art of emergence, we uncover not just the secrets of nature, but also a deeper appreciation for the interconnectedness of everything. When we look up at the night sky, we often marvel at its beauty. The stars twinkle like scattered jewels, and the Milky Way stretches across the heavens in a glowing band. It's easy to see this as a scene of perfect order, a grand design where every star, every galaxy, seems to have its rightful place. But the story of how the universe came to look this way is one of chaos transformed into harmony, a tale of raw, unstructured energy, giving rise to the astonishing complexity we see today. Let's start at the very beginning, or as close to it as we can get. About 13.8 billion years ago, the universe was born in an event we call the Big Bang. This wasn't an explosion in the traditional sense, but rather the rapid expansion of space itself, filled with energy and particles in a chaotic, high-temperature soup. There was no structure, no stars or galaxies, just an incredibly hot and dense sea of particles zooming around. Over time, this chaos began to cool and settle. Gravity, one of the fundamental forces of the universe, started to work its magic. Tiny variations in the density of matter, a little more here, a little less there, became seeds for structure. These denser regions exerted a stronger gravitational pull, attracting more matter and growing larger. What started as subtle differences became the building blocks of galaxies, stars, and planets. Chaos began to give way to order. One of the most fascinating aspects of this process is how simple rules gave rise to such intricate structures. Gravity, for example, is a straightforward force. It pulls objects together. But when you apply it across vast stretches of space to billions upon billions of particles, it creates stunning patterns. Galaxies form in spirals, filaments, and clusters, their shapes dictated by the interplay of gravitational pull, rotation, and the distribution of dark matter, an invisible substance that makes up most of the universe's mass. Take the Milky Way, our home galaxy. It's a barred spiral galaxy with a dense central bulge and arms that sweep outward like a pinwheel. This shape wasn't planned or designed. It emerged naturally from the forces at work. Stars within the galaxy orbit the center, following paths influenced by gravity and the galaxy's rotation. Over billions of years, these orbits created the beautiful spiral structure we see today. It's a perfect example of how cosmic harmony arises from the chaos of countless particles interacting under the same basic laws. The story of stars themselves is equally remarkable. Stars form from giant clouds of gas and dust, often referred to as stellar nurseries. These clouds are chaotic, with particles moving in all directions, colliding and clumping together. Over time, gravity pulls these clumps tighter and tighter, increasing pressure and temperature until nuclear fusion ignites. A star is born, a blazing beacon of order emerging from the chaos of a collapsing cloud. But stars are more than just sources of light and heat. They are cosmic forges, factories that create the elements necessary for life and complexity. When a star burns its hydrogen fuel, it produces helium. As it ages, it begins to fuse heavier elements like carbon, oxygen, and iron. When massive stars reach the end of their lives, they explode in supernova, scattering these elements across the galaxy. The chaos of the explosion seeds the universe with the building blocks for new stars, planets, and eventually, life. This cycle of creation and destruction is a cornerstone of cosmic harmony. Stars are born, they live, and they die, but their elements live on, becoming part of the next generation of stars and planets. Our own solar system, for example, formed from the remnants of earlier stars. Every atom in your body, the carbon in your cells, the calcium in your bones, the iron in your blood, was forged in the heart of a star billions of years ago. You are, quite literally, made of stardust. Galaxies, too, are dynamic and evolving systems. They grow by merging with other galaxies, a process that might sound violent but often leads to stunningly beautiful results. The gravitational interactions between galaxies create tidal forces that stretch and warp their shapes, forming intricate tails, rings, and spirals. These collisions aren't just destructive, they mix gases, trigger star formation, and help galaxies evolve into more complex and ordered systems. At the largest scales, the universe itself is a masterpiece of cosmic harmony. Galaxies are not scattered randomly. They form a vast cosmic web connected by filaments of dark matter. These filaments stretch across the universe, creating a network of clusters and voids. This structure is the result of billions of years of gravitational interactions. A grand symphony where each galaxy plays a part in the larger whole. What's truly mind-boggling is how much of this harmony arises from such simple beginnings. The universe started as a chaotic sea of energy and particles, yet it evolved into something so intricate and interconnected. And while gravity plays a central role, it's not the only force at work. Electromagnetism, nuclear forces, and even quantum mechanics contribute to the cosmic dance, each adding its own layer of complexity. But cosmic harmony isn't static. It's a dynamic balance. Stars burn out, galaxies collide, and black holes consume matter, creating new waves of chaos. Yet, from this chaos, new structures emerge. It's a continuous cycle, a reminder that order and complexity are not permanent states, but processes, always in motion. This dynamic balance has profound implications for how we understand the universe and our place in it. It shows us that chaos and order are not opposites, but partners in a grand cosmic process. It's a humbling realization, one that reminds us of the interconnectedness of everything. The atoms in your body were once part of ancient stars, and the light from distant galaxies carries the history of the universe itself. You are both a product of and a participant in the cosmic harmony that shapes everything. And yet, as we marvel at the order of the cosmos, it's worth remembering that this harmony is not the result of control or design. It's the natural outcome of simple rules playing out over vast scales of time and space. It's a testament to the power of emergence, the ability of the universe to create beauty and complexity from chaos. The story of cosmic harmony is far from over. Stars will continue to form, galaxies will keep evolving, and the universe will go on creating new patterns of order and complexity. And as we continue to explore and understand these processes, we gain not just knowledge, but a deeper appreciation for the elegance and interconnectedness of the cosmos. The universe is not just a place we inhabit, it's a symphony we're a part of, a grand and ever-evolving dance of chaos and harmony. As we come to the end of this journey through the intricate dance of chaos and order, it's clear that the universe operates on principles that are as awe-inspiring as they are mysterious. From the smallest particles to the largest cosmic structures, the interplay between chaos and order shapes everything around us, offering a glimpse into the profound mechanisms that govern existence. It's a story that's equal parts science, philosophy, and wonder, a reminder that even in the vast, seemingly chaotic expanse of the cosmos, there is a profound harmony at work. The universe is not static. It's an evolving, dynamic system where chaos and order are deeply interconnected. Chaos is not merely disorder. It's the fertile ground from which patterns, structures, and complexity emerge. It's the swirling clouds of gas that give birth to stars, the gravitational tugs that sculpt galaxies, and the countless tiny interactions that create the beauty and balance we see in nature. Chaos and order are not enemies, they are partners in the creative process of the cosmos. This balance is not just theoretical, it's something we can see and feel in our daily lives. Think about the patterns in nature that surround us, the branching of trees, the rhythm of waves crashing on a shore, or the spiral of a seashell. These patterns aren't just beautiful, they are the physical manifestations of the same principles that guide the formation of galaxies and the evolution of life. They remind us that we are part of a universe that thrives on connection and transformation. But the universe's ability to create order from chaos isn't just a scientific curiosity, it carries a deeper meaning. It shows us that the cosmos is not a random, meaningless void, but a place where beauty, complexity, and harmony can emerge naturally. It challenges us to think about our place in this grand symphony. Are we merely spectators, marveling at the universe's wonders, or are we active participants, shaping and being shaped by the patterns around us? In many ways, humanity itself is a product of the universe's talent for creating order out of chaos. The atoms in our bodies were forged in the hearts of stars, scattered across space by supernova, and brought together through billions of years of cosmic evolution. the complexity of our minds, the creativity of our cultures, and even the questions we ask about the nature of existence are all part of this ongoing process. We are the universe contemplating itself, a small but extraordinary part of the larger whole. And just as the universe finds balance at the edge of chaos, so do we. Life is full of uncertainties, challenges, and moments of disorder, but it's in these spaces that we grow, adapt, and discover new possibilities. The same principles that govern the formation of galaxies and the behavior of weather systems can teach us something about resilience, creativity, and the importance of finding harmony in our own lives. Chaos may be unsettling, but it's also where innovation and transformation begin. The philosophical implications of this are profound. If chaos and order are two sides of the same coin, what does that mean for how we view the world? Does it suggest a deeper logic or purpose behind the universe's workings, or is it simply the way things are, a natural consequence of the laws of physics? These are questions that have fascinated humanity for centuries, and while we may never find definitive answers, the act of asking them enriches our understanding of ourselves and the cosmos. As we reflect on the relationship between chaos and order, it's impossible not to feel a sense of wonder. The fact that the universe can evolve from a chaotic explosion of energy into a realm of stars, galaxies, and even conscious beings is nothing short of miraculous. It reminds us that the universe is not just a collection of random events, but a deeply interconnected system, where every piece plays a role in the larger pattern. This interconnectedness carries a responsibility too. If we are part of the universe's grand symphony, then our actions matter. The choices we make, the patterns we create in our own lives, and the way we interact with the world around us all contribute to the larger tapestry of existence. By understanding and embracing the principles of chaos and order, we can strive to live in harmony with the universe, finding balance in our relationships, our communities, and our connection to the natural world. The journey of exploring chaos and order doesn't end here. In fact, it's just the beginning. There is so much more to learn, so many mysteries still to unravel. Scientists are continually discovering new patterns and principles that deepen our understanding of how the universe works. Philosophers continue to ask questions about meaning, purpose, and our place in the cosmos. And as individuals, we have the opportunity to look at the world with fresh eyes, seeing the beauty and complexity that lie beneath the surface. As we move forward, let's carry with us the lessons of this exploration. Let's remember that chaos is not something to fear, but something to embrace as a source of creativity and possibility. Let's celebrate the patterns that emerge from the interplay of forces, from the spirals of galaxies to the rhythm of our own lives. And let's remain curious, open to the wonder and mystery of a universe that has so much more to teach us. Thank you for joining me on this journey into the cosmic dance of chaos and order. If this exploration has sparked your curiosity or made you think about the universe in a new way, I encourage you to like this video, share your thoughts in the comments, and subscribe to the Storyteller Panda. Your support helps us continue to explore these fascinating topics, and I'd love to hear your perspective. What patterns do you see in your own life? How do you find balance in the chaos? The universe is vast, intricate, and full of surprises. Together, we can keep exploring its mysteries, finding meaning and inspiration in the interplay of forces that shape our world and beyond. Until next time, stay curious, stay inspired, and remember, we are all part of the same cosmic symphony. Let's make our notes count.